Topic 4, Portfolio Optimization, Section 6. Constructing an optimal portfolio on the CAL or CALB given a vol target. Since the standard deviation of a complete portfolio. Now, when I say a complete portfolio, this is a portfolio that combines risky and risk-free assets or risky and borrowing. The standard deviation of that portfolio is the weight in the risky portfolio times the standard deviation of the risky portfolio. Now, if my client wants a 9% volatility portfolio, the optimal portfolio for a 9% vol, I'll plug in my formula. I want a 9% complete portfolio, also called a combined portfolio. I know that that portfolio is going to be on the CAL because 9% is less than the volatility of my optimal risky portfolio. Therefore, if I take 9 over 16, 9%, my target complete vol, divided by 16.23%, the standard deviation of the optimal risky portfolio, that gives me 55.47%. That means that 55.47% invested in the optimal risky portfolio. And the 1 minus that invested in treasuries is going to give me this point right here. So again, think about what we're doing. We're combining this risk-free asset with this optimal risky portfolio. The ratio of the volatility that I'm targeting, 9%, over the standard deviation of the optimal risky portfolio will tell me the weight that I'm going to invest in the risky asset. 1 minus that is the weight in the risk-free. Then I'll just take the weighted average return and figure out what the return is. And if I need to figure out the weights in the individual assets, I'll take the weight in the risky times the weight in the individual assets. So, back to our spreadsheet. I need to compute the weight in the risky asset. If I want a 9% vol, divided by the standard deviation of the optimal risky portfolio, I need to be invested 55.47% in the optimal risky portfolio. Zooming in there. 1 minus that is invested in treasuries or in the risk-free asset. The expected return of that portfolio, it's 55% invested in the optimal risky portfolio that has an expected return of 6.8 plus 44% invested in the risk-free asset. So I'll just say RF. So that portfolio is going to give me an expected return of 4.66%. Now, how do I actually form that portfolio? Well, if I had $100, I'd put $44.53 in the risk-free asset. Then I'd invest in these 3 assets that are a part of this optimal risky portfolio. How do I do that? I say equals the weight in the risky portfolio, anchor that, times the weight of the SPY in the optimal risky portfolio. I'll copy that across. So it's the weight in the risky times the weight of EFA in the risky, weight of the risky times the weight of EMA in the risky. Notice that if I sum up these 4 numbers, it adds up to 100%. So this is how you tell your client to build the optimal 9% vol portfolio. If the client had $100, put $44.53 in treasuries. The other $55.47 are going to be invested by $42 in SPY and $13 in EMA. That will give them an optimal portfolio. That portfolio should show up right here on my graph. Select data, add, we'll call this V2 with a vol of 9% and an expected return of 4.66. This is a good way to test if you got it right. It should show up on the line. So there it is. That is the optimal 9% volatility portfolio, giving these 3 assets, SPY, EFA, and EMA, risk-free asset, and borrowing. That's the optimal complete or combined portfolio. Now let's try to find the optimal 27% volatility portfolio. Notice that 27% is greater than the volatility of the optimal borrowing portfolio of 21.9. Therefore, you know it's on this line. And we're going to use the same procedure. We're going to take the weight, our target weight, 27% for our combined or complete portfolio, times the volatility of that risky portfolio we're going to add to it, 21.09. That means we're going to invest 128% of our money in our risky portfolio. 1 minus that is going to be invested in our, not RF, but our RB in this case. So let us construct that portfolio in Excel. Come down over here. I'm going to take my 27% targeted vol portfolio divided by the vol of that portfolio. That is my 128%, which means 1 minus that is in borrowing, so negative 28% in borrowing. That portfolio's return will give me 128% of the return of the optimal borrowing portfolio, plus the RB, the weight in the RB times RB. So that's going to be my financing charge. So that portfolio is going to give me a 7.98% return. How do I construct that portfolio? I take 128%, anchor that with the dollar signs, times the weights of the OBP in SPY, EFA, and EMA. Changing the formats there so the numbers pop up. And there we go. Let's make sure that that shows up on our graph right at 27%. So it should show up right around here. So let's go ahead and do that. Select data. Add, we'll call this V3 with a volatility of 27 and an expected return of 7.98. And there it is, right at 27% on this line. Now again, let's talk about how to construct that portfolio. If your client wants 27% volatility, you'll tell them to borrow $28. All right, so again, assume your client has $100. They're going to borrow $28 at 5.5%. Now they have $128. They're going to put 89 into EMA, 32 into EFA, and 6 into SPY. And that's how you build the optimal complete or combined 27% vol portfolio. So in this topic, we constructed an optimal portfolio on the CAL or CALB given the vol target. The next topic, we'll construct optimal portfolios given return targets.